So this is going to be a quick walk through the calibration process. It's currently pretty clunky and not very user-friendly, so we're going to be working on making it better in the near future. So expect this process to change a bit, but also it's pretty clunky and not user-friendly, which is why we want to make a video explaining how to do it, because it seems like a number of people are stuck there. All right, so we're going to start out on the computer, and let me see, am I recording my screen? I am. Okay. So we're going to start it on the computer. We're going to connect to our machine. We're going to click here on the Fluid NC tab. We're going to open our local files. These are the files that control the machine. So there's index.html defines what the user interface looks like. Maslow.yaml contains all of our machine's configurations. And preferences.json, I don't even know what that one does. But the one we care about is maslow.yaml. So we're going to download our maslow.yaml file, and then we're going to open it up. And we're going to go in here, and the first thing we care about are these guys. So this is just our rough dimensions of our frame so that we can generally extend enough belt to begin the calibration process. So I'm just going to set these to roughly 2,000 and 3,000 millimeters. So there's 3,000. And let's then save this. Oh wait, mine's got a number in it. Gotta make sure it's got the right name. So we're gonna save it as maslow.yaml. And now we're gonna go back to our program here. Oh, and one more thing we wanna edit in that maslow.yaml file. We wanna look at, do we want vertical or horizontal? So we are going to set this to false because we're going to do horizontal calibration first. Okay, so we'll save it. The one more thing we could change in here, this calibration offset sets how far from the corners of the frame we put our test points. We could mess with that if we wanted to, but you don't need to mess with that. That's just what that number does. Okay, back here in our FluidNC local file system, we are then going to upload our file again with our new settings in it. Great. And now let's restart the machine. So we're going to be starting out with our machine configured basically like as if we just put it together. So all of our belts are sort of some random length from when we assembled it, and the z-axis is way up high. And first thing we want to do before we start the calibration process is lower the z-axis all the way down. So we're starting at a known height, which we've just arbitrarily picked to be all the way at the bottom. So we're going to click on alarm here to unlock the machine, and then we're going to click on Z, and we're going to lower it down. So I'm just going to change the amount so I don't have to click a million times. And when I click down, the z-axis is going to lower down. And we're just going to drive the z-axis all the way down until it hits the bottom, stops there. So we can keep going a little more. And you'll hear that it bottoms out, and you're not going to hurt it by continuing to drive it into that lower stop. The next thing we're going to do is click on Setup, and then we're going to click Retract All. And this is going to fully retract all four of the belts. And that's just so the machine starts out in a known configuration, which is z-axis all the way down, belts all the way retracted. Now that we've got all four of our belts retracted, we're going to click on Extend All. And Extend All, you're going to hear the cooling fan come on. And then to actually extend the belts, we need to pull them out. And they can be a little hard to get started. So there's a sort of a rocking motion that can help free those up. I'll get a close-up of that. And you can do the belts one at a time. You can do them two at a time. Whatever you prefer. You just have to keep pulling on them gently to keep them extending, and they'll automatically extend out so that there's more than enough belts to reach the corners of your frame based on the dimensions we put in our configuration file. So now all 4 of our belts are extended to the full stops as far as they want to go, and you'll hear the cooling fan turn off. So now all of the belts are extended and we're ready to attach our machine to the frame. So we're going to take each of our belts, making sure there's no twists in them or anything like that. We're going to extend them. Oh, that's the wrong one. We're going to extend them to the 4 corners. And there will be more than enough slack. So they should fit easily with some left over. All right, so all 4 of our belts are attached. And notice that there's a lot of extra slack here. There's, plenty of slack in the belts, and that's totally normal. So the next thing we're going to do is on the computer, maybe let's tidy up our cables just a little bit, keep them out of the way. And you want to make sure that you've got enough power cord for it to reach everywhere, because it's going during the calibration process, it needs to move across the entire frame. So, you got to have some space, or at least have enough power cord to be able to reach everywhere. I've definitely made that mistake. All right, now we're going to click the calibrate button. And what's going to happen is our machine is going to use 2 of its belts to pull itself around. So right now it's going to use the lower 2 belts to pull itself to the center. And it's going to extend the other 2, or it's going to pull itself down. And now it's going to use these 2 belts to pull itself to that side. Now during this process, it's basically 2 of the belts are slack. So it's extending extra slack to allow those belts to move. And it's not the best at knowing exactly how much slack to extend. Basically, it's doing this because it doesn't know its frame dimensions right now. We just put in random numbers of 2,000 and 3,000. So it just knows it has to have enough slack to move, but it doesn't know how much that is. So I like to tend the belts a little bit there and try to make sure that they're always not getting sort of tangled up. And it's really that first big move that's the most prone to getting tangled, just because it's such a big move. After that, all of the moves will be much shorter. So we can see here we're at our first location. We're taking a measurement. It's taking a measurement there. It's moving to our next location. There's a little bit too much belt unspooling on that one, so I'm going to just tend to it a little bit. Let me get a close-up shot of what tending to it looks like. So we're taking a measurement, and this whole process can be sped up quite a bit. It used to be much faster. We changed things and it got slower. We'll make it fast again. So you can see as it's moving to a new location, there's sort of extra belt unspooling there. So I'll just kind of give it a little tug on this guy, just to help it not have that extra belt spool up. So it goes tight again, takes a measurement. Same thing. So it's moving to the new location. There's a little bit extra belt there. I'll just give it a little tug. You don't really have to do that. It's just nice to keep an eye on it, make sure it's not getting excessively unspooled. All right, so now the calibration process has finished. So we're going to close this. We'll scroll down here and we can see our calibration results here. And it might take a few minutes for those to appear. Basically, it's non-deterministic how long the calculation will take. So it keeps refining its measurements until it gets better. And it's also going to depend on how fast your computer is, because this calculation is actually done on the computer itself because the processor is so much faster than the ESP32 running on the machine. So basically, we're going to take these numbers here and we're going to copy them, and we'll open up our configuration file, and we're just going to put these in for our coordinates. And the fitness is just a measurement of how good our calibration process is. 0.7 is about what I usually get. Higher numbers are better. So the higher that number is, the better it was able to fit the points it found to the anchor points. So we're going to save this file, and then we will go back into our local files here. We're going to upload our file, our new edited file. We'll let that upload. Oh. All right, so I'm just going to delete the old one to make space for it. We're working on making our index.html file smaller, so you won't have to do that, because right now we're like at the limit. Okay, now let's restart our machine. You can also just unplug it and turn it back on again. And then we are going to disconnect all 4 of our belts. So we're going to then, are we recording? Yeah, we are. We're then going to, so we're back in our alarm state here. We're going to set up, and we're going to do retract all. So we've got all 4 of our belts retracted now. And we're now going to do extend all again. We're then going to hook the belts up to the frame again. And from now on, the calibration process, again, is something you only have to run one time when you build the frame. So from now on, basically, the process would be extend the belts, attach them to the frame like this, and the machine will automatically extend some extra. Just to make it easy to extend them or to attach them. And now that we've extended all of our belts, we're going to click on, we don't need to run the calibration process ever again. We're just going to click on Take Slack. And this is going to basically tension up the belts for us automatically, so our machine's ready to use. And from now on, all we have to do is the extend all and take slack steps when we want to set up our machine. The calibration is just something we run once the first time we build the frame. And now our machine is ready to move around. So we can move it around with the arrow keys here. And you can see as the machine moves around, now it knows exactly where these anchor points are, so it's going to keep just the right amount of tension in each of the belts. The calibration process for the vertical orientation is almost identical. What we're going to do is we're just going to open up our same maslow.yaml file, our configuration file. This time we're going to set our orientation vertical to true. And these numbers are all just some rough guesses for how big we think our frame is. We just built it. We can just, guesstimate. These numbers, literally their only purpose right now is to make sure that the machine extends enough belts so that we can hook it up the first time. We're then going to go into our files here. We're going to replace our configuration file with the new one. We're going to restart the machine. And from here, we are free to go into here. Start off retract all. Even though our belts are already retracted, we still always have to do that step just so the machine knows they're retracted. Then we'll click extend all. We'll extend out our belts. So with our belts extended, we hook it up on the frame, but this time it's vertical. All right, slight technical difficulty. Well, I found the right pins or the right bolts for the corners of this frame. I didn't find quite the right ones, but I found some that will work. So basically, same as in the horizontal configuration, we hook up each of our corners. Belts. Brief pause while the camera battery got replaced. All right, so we put all 4 of our belts in, and then from there, the process works exactly the same. We press the calibrate button. And the process is almost identical, except this time around, in the vertical orientation, the machine is exclusively going to use these 2 belts to reposition itself. So the lower 2 belts are always the ones that are slack, and the upper 2 belts are always the ones that are extending. And again, especially on this first long move, I sort of like to keep an eye on how much slack the machine is putting out. Basically, you can give it a little tug and then take the pressure off to help it extend the right amount. And now it's just going to go through the same calibration process as before, except this time it's going to do it in the vertical orientation. I'm not going to show the whole vertical calibration process because it literally is identical. There's a bajillion ways we can make this process better. Does it need to pause for this long at each stopping point? Probably not. Do we need this many points at all? No. The math technically only needs 3 points. Right now we're doing 90, I believe. Maybe it's 100. So we could definitely use fewer points. You know, where on the sheet are the most important points? There's so many ways that we can improve this process, make it easier, make it faster, make it more user-friendly. Like the fact that we can't edit the configurations file directly from within the firmware. We have to download it and edit it and re-upload it. Super annoying. That comes from FluidNC, which is what our software is based on. And yeah, I think we can change that. There's a ton of ways we can make it better, and we will make it better, so expect it to change soon. I expect to see progress on that. But it's also something you only have to run once the first time you build your frame. So it's a frustrating process, but once you're through it, you won't have to do it again. Yeah, I hope that helps. And let me know if you guys have any questions.